Hello and welcome to the session. In this session, we are going to discuss about implicit differentiation and its application in finding rates. Let us first try to understand what an implicit function is. An implicit function is a function in which we cannot express a dependent variable in terms of an independent variable. That is, we cannot write a function in the form y is equal to fx. For example, x square minus xy plus y square is equal to 0. In this equation, we can neither express y in terms of x or x in terms of y. Note that the functions in which we can express dependent variables in terms of independent variables are called explicit function. For example, x square minus 3 plus y is equal to 0. We can write it as y is equal to 3 minus x square. So here we have written y in terms of x, that is y is equal to fx, so it is an explicit function. Now, implicit differentiation helps us to find dy by dx without solving for y. While differentiating implicit functions, we must keep two things in mind. First, since we are treating y as a function of x, so derivative of y is written as dy by dx. The second thing which we have to keep in mind is we use chain rule in order to differentiate y with respect to x. That is, suppose we have to differentiate y square with respect to x. So, we have d by dx of y square equal to 2y dy by dx. Here, first we differentiated y square and using chain rule, we differentiated y with respect to x. Thus, in general, d by dx of y raised to power n is equal to ny raised to power n minus 1 dy by dx. Thus, to differentiate implicitly, differentiate both sides of the equation with respect to x, or whatever variable you are differentiating with respect to. Use the rules for differentiation, that is the power rule, the product rule, the quotient rule, chain rule, etc. as necessary. Next is to keep all terms of dy by dx on one side of the equation and bring all other terms on the other side of the equation. Next, we factor out dy by dx and solve it by dividing if necessary. Now consider the following example. Differentiate 4x cube y square plus 3y equal to minus 15. We use implicit differentiation to solve it. Differentiate both sides of the equation with respect to x, that is d by dx of 4x cube y square plus 3y is equal to d by dx of minus 15. We can write it as d by dx of 4x cube y square plus d by dx of 3y is equal to d by dx of minus 15 using addition rule. In the first term, we have two functions, x cube and y square, so we use product rule. So we get 4 into x cube d by dx of y square plus y square d by dx of x cube plus 3 into d by dx of y is equal to d by dx of minus 15. This implies 4 into x cube 2y dy by dx plus y square into 3x square plus 3 dy by dx is equal to 0, as the derivative of a constant is 0. This implies 8x cube y dy by dx plus 12x square y square plus 3 dy by dx is equal to 0. Now on collecting all the terms of dy by dx, we get 8x cube y plus 3 the whole into dy by dx plus 12x square y square is equal to 0. This implies 8x cube y plus 3 the whole into dy by dx is equal to minus 12x square y square, which implies dy by dx will be equal to minus 12x square y square upon 8x cube y plus 3. This is the required differentiation. Now we come to related rates. Suppose we have z, a function of y, and y a function of t. We want to find dz by dt. So for this, we cannot directly differentiate z with respect to t because z depends on y and y depends on t. So here we use chain rule. That is, dz by dt will be equal to dz by dy into dy by dt. Here we have first differentiated z with respect to y and then further differentiated y with respect to t. And thus, rate of change of z is related to the rate of change of y. Let us see one example. The profit earned by a company in selling X units of a product is given by P equal to minus x square plus 3100x minus 2500 if the product is sold at the rate of 25 units per month. At what rate is the profit changing when 450 pieces have been sold? So here we are given quantities sold per month. Month represents time period. So profit P and quantity X sold both are changing with respect to T. So rate of change in profit with respect to T will be given by dP by dt and rate of change in quantity sold with respect to T will be given by dx by dt. We have the following equation: P equal to minus x square plus 3100x minus 2500. We differentiate both sides with respect to t and we obtain dP by dt will be equal to d by dt of minus x square plus d by dt of 3100x plus d by dt of minus 2500. And we get dP by dt is equal to minus 2x dx by dt plus 3100 dx by dt minus 0. Hence dP by dt is equal to minus 2x dx by dt plus 3100 dx by dt. We are given that the product is sold at a rate of 25 units per month. That is, rate at which the product X is being sold per month is dx by dt, which is equal to 25. Also, we have to find the rate of change in profit that is dP by dt, when number of sold units, that is X is equal to 450. So first, when dx by dt is equal to 25, dP by dt is equal to minus 2x into 25 plus 3100 into 25, which implies dP by dt is equal to minus 50x plus 77,500. So now on putting x is equal to 450, we get dP by dt is equal to minus 50 into 450 plus 77,500, which implies dP by dt is equal to minus 22,500 plus 77,500, which is equal to 55,000. So, the company's profit is increasing by $55,000 per month, which is the required answer. So in this session, we have discussed implicit differentiation and its applications. This completes our session. Hope you enjoyed the session.